actually use in a local-only mode, or you can use it in a distributed mode. Again, the key value stores. Many of them will actually do some kind of a disk backing, where it will do some kind of an append-only file, where it will periodically write out information onto the disk, so in case it goes down, it will be able to come back and have some or most all of your information available to it. So some of the products, Couchbase is a fairly recent creation of Membase plus CouchDB. So we're trying to take the best of both of these worlds, the document store and the memory store, and combine them together into one kind of product. And then CacheD, which is more of a local map, but it does have a scalability model for multiple nodes. Coherence, which is a commercial Oracle support, is quite an interesting product there. So you can do local node distributed. So if you have 10 or 15 or 20 web servers, you could actually use some kind of distributed cache behind that to be able to reference, often use information, maybe session data or something. Redis is actually quite interesting. They're a little bit different in the data model. They support hashes as well as lists, sets, sorted sets. They refer to themselves as more of a data structure server. So they support things like really fast set operations. They have very high-speed counters. So if you need a counter that you can increment, 100,000 times per second or something like that, it supports it really well. Tokyo or Kyoto cabinet is one of the disk back map varieties. Infinispan is Red Hat, and they're implementing the JSR level 7. There's actually a new JSR that's come up. JSR level 7 is kind of dead. I don't want to say the wrong one, but there's a newer JSR that kind of expands on JSR level 7. It's quite interesting. And then Scaleris is actually written in Erlang. Some of these products are written in Erlang. Erlang and Java tend to be the two most common ones. And they focus very much on strong consistency for your information. So graph and triple stores. So what these are designed for is modeling relationships. Bill knows chart, right? That's some relationship. You have a subject, you have a predicate, which defines a relationship, and then you have an object. And these are referred to as RDF triples, part of the semantic web. So trying to bring some understanding to all the information that we have out on the web. So it's basically made up of a series of nodes and edges. So you have two nodes and you have an edge that connects those. And most times that edge can have weight to say how strong that relationship is, or other characteristics that define that relationship. Most of them implement Sparkle, which is a type of SQL or SQL-ish kind of language that is built for this particular space. And then most of them support an object mapping API as well. A lot of the products in the space are very mature and very well used. Sharding is a little bit more difficult in this space because you're dealing with a series of connected nodes. And so the problem is, if I've got a bunch of nodes and they're all connected together, how do I separate them onto multiple machines and also be able to query them really efficiently? Again, schema doesn't really apply. You've got nodes and edges and properties. That's about it. Really good for set operations. So it's basically how places like Facebook know, your friends and your friends, they know whose friends are in common, right? And they can do that very, very quickly.
That's a quick question. If you're dealing with nodes, edges, and weight, is that just a one-to-one relationship, or can you go many, one-to-many?
Yeah, you can go, they could be unidirectional, bidirectional. You can bring in, the graphs can get...
So pretty much anything you want to do.
Sorry?
So pretty much any way you want to do.
Yeah. It's one of these products that's a little bit more specialized, but if you have a model that fits it, it works really, really well. Extremely well. Two of the top ones are Neo4j and LaborGraph in this space. Neo4j gives you full ACID transactions with an object-oriented API. Allegro Graph was one of the first to do Sparkle. Big data is the name, it's a general term and the name of a particular product in this case. They're very, very good with dynamic sharding. Trinity is quite interesting. It's a Microsoft research project, and as such, it runs on Windows only. It's one of the very few that do that. Infinite Graph, they focus a lot on distribution and cross-platform. Several of these are, I think, Neo4j, Allegro Graph, and Infinite Graph are Java-based. FlockDB, Twitter went out and they were trying to find, they have some particular problem sets. If you've got someone, if you send out a tweet to a bunch of people and they've got millions of users, how do you find those particular sets, those unique individuals, in a tenth of a second or less, right? And how do you do that on a very, very huge scale? They didn't have anything that they worked, so they wrote FlockDB, which they then open sourced. And it's not quite as general purpose in Graph as some of these other things, but they build up the fast set operations combined, and it works really well for them. InfoGrid is another one of these. They're more object-based, and they put a REST API, which is on top of it. There's quite a few of these that have a REST API, and it's quite nice because you can go in even on a command line and tool around with curl or something and be able to interact with these things and see how they go. It makes them pretty easy to implement in multiple languages. Everything speaks HTTP at some point, right? Some of the, so this is a new slide I actually put in just a few days ago. So I'm calling this interesting integration. So a number of the products in the NoSQL space support no or kind of a very limited kind of a query language. And the document store, you have a key and a value. If you don't know the key, it's going to be difficult to get that value back out of the database again, that data store. And so a number of products now are actually taking Lucene and integrating it with their products at some level, which makes a lot of sense, right? So Solar and Elasticsearch actually take the Lucene core. Lucene essentially is just a search engine. So Solar and Elasticsearch actually take and wrap that, and they give you REST interfaces, they give you either XML or JSON formats to be able to put in and out of it very easily. They give you a couple of different scalability models, so you can take Lucene and really make it work for you. Solar in particular is a hugely popular project. React Search is interesting in that React is written in Erlang, and they have a project where they're taking the Lucene APIs and implementing them in Erlang, and actually allowing you to take some of the Java code, the analyzers and parsers and stuff, and run it against React. Solandra, which is another twist on the scalability model, so they're taking Lucene and putting it on a scalable Cassandra backend, which is quite interesting. CountsDB and Lucene is a project that's out there that does a similar kind of integration. There's distributed Lucene, which is part of the Apache Hadoop project. I'm not sure if they're doing development on it right now or if it's just a suggestion, but the idea is to, again, put Lucene on top of Hadoop and make it scalable. Neo4j is one of our graph stores that implement the Lucene APIs and give you full text search on graph store, which is quite interesting. So it really takes these products and really puts them at a whole different level. And then I call this one worth mentioning. So there's a couple other products that kind of tie into this space on a little bit of a different level. One of them, or a couple of them, I'm calling basically configuration DB. And these are designed with certain services that can be used to make other applications scalable. So for instance, they provide distributed configuration. If you've got an application that's running under 100 nodes, how do you configure all those things and make them consistent? It's a big problem. Distributed locks and distributed synchronization operations as well, or facilities, I should say. And Doozer tries to up one on Zookeeper by